All right, let's continue with number 8. The slope field for a certain differential equation shown above, which of the following could be a solution to the differential equation with the initial condition of y of 0 is 1. So I want to go to 0, 1, and I want to trace something that kind of follows those curves. So it comes through horizontal, and then everything immediately starts taking a downward turn. And it gets steeper. Then it starts leveling out as we get closer to down there. Same type of thing here. It's going to come down. And again, look for that symmetry. It should look somewhat symmetrical as we build our slope field. All right, so now what I'm looking for is a function that has that shape right there. Okay. So first of all, this is a cosine of x, so this is what's called sinusoidal. So again, this is that type of sinusoidal function. This looks like it could be it. This is an inverted parabola. So this should look something, that's terrible, but it should look something like this here. And again, this here curves up. A parabola does not. A parabola gets steeper and steeper on either end. So B is out. Again, we know what e to the x looks like. E to the x looks something like this. This is definitely not e to the x. Might not be as familiar with D here, okay? But this is actually the graph of the, how should we say it? It's a semicircle with, it's the upper part. So it's the upper part of a semicircle. If it was a negative here, that would be the bottom part of the semicircle. So again, it's not going to flare out at the end like this here does. So it cannot be D, therefore A is the only option. Number 9, shown is the slope field for which of the following differential equations. And so again, we look at this idea that if x is 0, okay, and let's do that even down here. Let me actually zoom out just a smidge so that we can write below and still see the slope field. So again, if x is 0, then in all of these, dy dx is 0. So actually, let me go back up here. Apologize. And if y is 0, in all of these, dy dx is undefined. So again, we see on the y-axis all horizontal slopes, on the x-axis all vertical slopes. So we really can't do anything else for that there. We've got to go kind of quadrant by quadrant by quadrant. Now again, if we take a look at quadrant 1, where x is positive and y is positive, then dy dx, no matter how you set that up, you're doing x over y, x cubed over y, whatever, we're still going to get positive. So that's fine in all 4 quadrants. Okay. Let's try quadrant 2. So in quadrant 2, x is negative, y is positive. And if we look at all of these slopes here, these are all negative. So dy dx is less than 0. So let's see when that's true. With x is negative and y is positive. Negative over positive is negative, so A works. X cubed or negative cubed is negative over a positive, that's going to be negative. If you square a negative, that's positive over positive, so we lose C here. And if you can check D, D would actually work as well. Let's move on to quadrant 3. Here, both x and y are negative, and dy dx is, everything is negative. So let's see here, a negative over negative is positive, A is out. Cube a negative, that's negative, over negative is positive, so B is out. Let's just check to make sure that D actually works. If we cube a negative, that's negative. If I square a negative, that's going to be positive. Negative over positive is negative. D is the answer. The next video will be number 10.